Hi, I'm Adam, a fourth year electronic engineering student at Southampton, and today I'm going to be talking you through how to use the logic section of your logic and arithmetic kit. The logic section is the top half of the board and is split into three parts: inputs, logic gates, and outputs. But before we get ahead of ourselves, the board needs power. So check that there's a AA battery in the holder on the back of the kit and hit the power switch in the top left corner of the front. You'll know it's on because the front will be lit up like some kind of Christmas tree. These are LEDs, or light-emitting diodes, and they show that a logic value is at logic 1 when lit, or logic 0 when unlit. So, let's start our overview of the logic section with the inputs. You're provided with two different input methods: fixed inputs, in the form of logic 0 and logic 1 sockets, and switchable inputs in the form of switches. One thing to be careful of is that you don't directly connect logic 0 to logic 1, as this may short-circuit the battery, which is at best ill-advised, at worst messy. However, you'll notice that the wires provided you with should make this impossible, as one end has a pin and the other a socket. The logic gate section provides a series of 2-in-1 input gates, each labelled with their standard symbols, with inputs on the left and outputs on the right. If everything is working correctly, you should already see the gates and inverting outputs, the ones with the little circles on the right hand side, outputting logic 1. Finally, the output section provides 3 pins with LEDs indicating their logic states, as you may wish to more clearly show the outputs from your circuit away from the tangled mess of wires you could end up with in the logic gate section. Now, to get you started, I'm going to present a logic problem and then proceed to solve said problem on the logic kit. Let's consider a form of airlock system, where you have two rooms that can be either at low pressure, logic 0, or high pressure, logic 1, separated by a door, the kind of thing you'd see on a space station. The door can be opened and closed using a switch, but because you're a responsible engineer and don't want people getting sucked into the vacuum of space, whenever the two rooms are at different pressures, the door is forced shut, logic 0, and the switch does nothing. So, to summarise, we have 3 inputs to our logic circuit: the 2 pressures of the rooms, J and K, which are either high or low, and the door control, input L. Whenever J and K are different, we want the output to be 0, and when they're the same, we want the output to be L. To work this out, let's start by creating a truth table for the system. There are 2 rows containing y equals 1, which we can combine into a logic equation for y. Y equals L and not J and not K, or L and J and K. If we then factor out the L, you may recognise the bit in the brackets as an XNOR gate. However, our board doesn't have an XNOR gate, so instead we'll be using an XOR followed by a NOT. This leads us to the logic circuit and equation y equals not J XOR K and L. Now all that's left is to build this on the logic kit. First, connect switching inputs J and K to the inputs of an XOR gate. Then connect the XOR's output to a NOT gate. Then the NOT gate's output to an AND gate. The other AND input should come from the switching input L, our door control. And finally, the AND's output should go to one of the output pins. When we play around with the door control with the same pressure in the rooms, the output LED will flip on and off, showing the door is opening and closing. But then when the pressures are different, the LED is forced off, meaning we've succeeded in saving our space station inhabitants from a cruel death in the cold depths of space. So this has been my demonstration of the logic section of the logic and arithmetic kit. I hope this has been helpful for you and hope that I'll be seeing you in the next video on the arithmetic section.